So, let's open Unity Hub and create a new project. Select the 2D template, call it E3 Project Structure, and save it in the same folder as the previous one. Once the project is open, go to the Layout menu and select My Layout. In the project panel, you can see all the files that belong to your project. Inside the Assets folder, you have your own files like images, 3D models, sounds, etc. In the Packages, you have access to other components that Unity preloads on your project and need to run properly. To keep this class simple, let's close this folder and ignore it for now, but never delete it. If you right-click on the Assets folder and select Show in Explorer, in Mac should be Show in Finder, you go straight to the folder in your computer. Going back one level, you see your projects folder. Inside, you have these 7 folders. The Asset folder is where you put the files you need to make your game. And all of the others, just don't touch them. Now, let's say you want to add an image to use in your game. You simply copy it to the Assets folder. In this case, I will add my logo to the game. Returning to Unity, you can see that the image is now present on the project panel. Here, you can also create folders to keep your project organized. This is very important because very quickly projects can have thousands of files and it can be very hard to navigate them if there is no organization and lots of untitled files. What is inside the project panel is just your files in your computer. Your game does not use all those files just because they are there. You need to add them to the scene. A Unity project just has 3 main, let's say, elements, and all your files should be one of them. The main one is the scene. This is where your game actually is. The scene is composed with game objects, and those game objects are controlled by components. So, when you are making a game in Unity, you are just putting together scenes, game objects, and components. Whatever is inside the scene will run when you play the game. You can have multiple scenes, for example, to have multiple levels in your game. Every scene is composed of game objects like sprites, terrains, sound, planes and tanks, etc. Any game object in your scene needs components to exist, be present, work and react to the world and other objects. These are the main rules. A scene is composed of game objects that are controlled by components. I will say this again with other words. A level is composed of characters that are controlled by scripts. Unity offers a lot of pre-built components that help game developers to focus on the art and the mechanics of the gameplay and build it. And that's the purpose of Unity as a game engine. Provide mainly common functions to deal with read a file from disk or render a pixel to the screen, for example. So, in order for you to make a game, you need to plan the structure of the scenes, make all the assets and compose the game objects and add or code the scripts and behaviors that control them. As an example and first exercise, let's make a microgame using all of these concepts. The game will have this structure. An intro scene that shows my logo and the game name, a main menu to play or quit the game, the playable level, a game over winning screen, and a game over losing screen. When the game starts, the intro shows for 2 seconds. After 2 seconds, it loads to the main menu. If the player clicks on quit, the game turns off. If the player clicks on play, the level scene is loaded and starts to run. The level is composed of 3 buttons. The computer randomly selects which button is the correct one, but doesn't tell you. The player needs to choose the correct one by clicking on one of the buttons. After clicking, the game ends, and if the button was the chosen one, the winner screen is loaded. If not, the game loads the losing screen. After one of those screens loads, the game returns to the main menu and you can start again. This exercise is just to exemplify the structure and explain what a scene, a game object, and a component is. I will make this microgame without a deep explanation of the code. So, because we already have a layout for the scenes, let's start by creating all the scenes we need for this game. I can simply create them one by one, but all of them will need some of the same game objects with the same settings, so it is more efficient to make one, work on one scene, and after those game objects are ready, I will just copy the scene and rename the duplicates. I'm talking specifically about the canvas. If you need any kind of text UI or buttons, you will need a canvas. Up here in the hierarchy panel, you have a sample scene. This one was created by Unity on the new project. Inside the scene, you have a game object called MainCamera. If you click on the object, its properties will be shown in the inspector panel. If you look careful, you see 3 components, all native from Unity Engine: the transform, the camera, and the audio listener. The transform is mandatory. Every object inside the scene needs to exist in a location with a rotation and a size. This component is the one responsible to handle that. At this point, you need to understand that the transform, as any other, is just a script file somewhere inside the Unity's core. You can technically write your own transform, but let's not reinvent the wheel again. The camera is also a script that finds a way to send information about the position of all objects to the rendering engine, so your world can be displayed on screen. The audio listener is there to deal with the position of all sounds in case where the sound have a 3D location and needs to be played at a different levels, pitch, panoramics, etc. So all the calculations will be made from the point where this component is. In this case, the camera. As you can also see, the components have variables to adjust their behaviors, so everyone will be different from the others. For this exercise, let's change the camera background color to white. As you can see, in the Edit Scene panel, we have this little screen at the bottom that previews what the camera is seeing. If you click on the game panel, you are actually seeing the render from the camera. This game panel is the final view and interaction, is what the player will see and touch. Now let's go back to the scene panel and let's add a new game object with a canvas inside to allow us to write text and have buttons. To do that, we can right-click the hierarchy panel and select UI, Button Text Mesh Pro. This TMP importer will pop up and you import it. For now, you don't need the extras, so you can just close this floating panel. In the hierarchy panel, you can see your scene with 3 more game objects: the canvas, a button as a child of the canvas, and an event system. If you scroll down in the scene panel, you can zoom out. As you can see, the canvas is giant compared to the camera, but if you go to the game, you see that all fits the camera render area correctly. In the hierarchy, select the canvas. In the inspector, you have the canvas component. There, change the render mode to Screen Space Camera and drag the main camera from the hierarchy to the render camera variable in the canvas component. Let's zoom in, and as you can see, the canvas now has the same size as the camera and it's at the same location. In the canvas game object, find the canvas scaler and select Change with Screen Size. Give a reference of 1920 by 1080. We should also force the camera to be in a fixed aspect ratio. We can do that in the game panel, clicking in this aspect drop-down menu and selecting 16:9 aspect. Even if the window changes its shape, the camera will have the correct aspect. Now let's make the button bigger and have another. Select the button and with the Rect tool, by pressing this button or the T key on the keyboard, adjust the size and position. If you unfold the button's game object in the hierarchy, you will find another object as a child. The text has the component to render text to the camera. Change the text to play and the size to 70. To finish this little setup, let's just add a title to the screen. Right-click on Canvas, select UI, Text, Text Mesh Pro. You can rename all game objects. You will call this Title and the button Button Play. Select the title text object and change the text to Main Menu, size 100 and centered align. Now open the text box and move it to the top. Also change the color. Remember that the background is white. Select the game panel and check the result. Now we have everything to start copying the objects and the scenes. First, I will duplicate the play button. Move it down, change the name to button quit and the text to quit. If you drag the text box away from the button body, just undo and select the button parent in the hierarchy. Now you can move correctly. Our main menu scene is ready and we can start copying it to make all the others. As you can imagine, in the duplicates, the canvas will be ready and set up correctly. So we avoided making all these 5 times. Before duplicating the scene, let's save the scene by pressing Ctrl S or File Save, and you should see the asterisk disappearing from the scene name. This means that the scene is saved. In the Projects panel, unfold the Scene folder and rename the scene to Main Menu. Because you are changing the name of the active scene, Unity is asking to reload. Do it. Now, with the main menu scene selected, click on Ctrl D to duplicate. Do it 4 times. Let's change the names of the duplicates to Intro, Level 1, Windscreen, and Loose Screen. In the hierarchy, we are still in the main menu scene. To edit other scenes, you go to the project panel and double-click the scenes you want to edit. So, double-click on Intro. Apparently nothing changed. Well, actually, we are in the intro scene. Don't forget it's a copy of the main menu and should look the same. You know you are editing the intro scene because in the hierarchy panel you can see the name of the scene at the top. So let's clean this scene and make it like an intro scene. Select the buttons and delete them. Drag the logo image into the canvas, resize and reposition it. Change the title to display the name of the game. Let's call it Random Button the Game. You can be artistic here. Double-click on the windscreen scene and Unity is asking if the changes done on the intro are to be saved. You click Save. This is because the intro scene will be closed to open the windscreen scene. Now, let's change the background color to a green and the title to Winner. We can also delete the buttons from this scene and be artistic again. Now, double-click on the lose scene and do the same for the losing situation. For last, open the level 1 scene and create the interface of the game. We will need another button. Change the text of the buttons to A, B, C. Also change the title to select the correct button. Adjust color and sizes to your taste and save. Now if you double click every scene, you see that the several screens needed to our game are done. This means the ingredients of the main structure are ready. We also understand now that any scene needs some components to populate the space in front of the camera, if we want our game to display something. Every scene is independent and during gameplay we jump between the scenes as needed. Unity does not know yet which scene it should use to build the game. To set up that, you go on File, Build Settings. You need to drag all the scenes you need in your game to this window. Just remember that the scene in the 0 position will be the first to open when you run the game, so change the intro up there. You can close this panel and the project can now jump from one to any of the other scenes. Open the intro scene and click on the play button at the top center of Unity window. Now the game is running. Without removing the play, go to the scene panel and delete the logo image. If you return to the game panel, you can see the logo disappear, as expected, but Unity didn't delete that because the game is running. While the game is running, you are allowed to edit stuff, but for testing purpose only. As soon as you stop the play, and no, the pause button is not stopping, the scene will be restored to the state it was at the play moment. So don't start editing extensively to discover later you will have to do it all again because you were doing it during play. This is one of the most common issues my students have. Never edit with the play on. So yeah, we can hit play, the scene is running, but the game is doing nothing. Well, it's doing nothing because we didn't tell it to do something. It's at this point where the scripting is necessary. You can use all the Unity's components, but those are not for game mechanics. If we need to change scenes and random select a button, we need to create that code and apply those scripts to the right objects. We are in the intro scene and we need to jump to the main menu. We can hard code a script to do that, but it will only change from intro to main menu. What we should do is a script that changes scene according to some parameters. In this case, we need the name of the scene to load and the time we need to wait before that happens. As I said in the beginning, this video is just to give you a general sense of the structure, including scenes, game objects and components. So I will not explain in detail the code I'm about to do. I guess you should be able to understand it if you really pay attention to it, so just copy what I'm about to do and see the thing working. Right-click on the Assets folder and create a new folder called Scripts. Right-click on the Scripts folder and select Create, C# script. Don't click anywhere. The name of the script is already selected. Just write ChangeSceneOnTime. Notice the capital letters in the beginning of each word. Do it like this. A good standard is to have capital letters in the script names, and the other capitals is to facilitate the reading. You can't have spaces in the script's names or variables or in general. Now you click on Enter and the script will be created with that name. Why this is important? Because when Unity creates a script, the main class will have the name of the script and those need to match. If they are different, the script doesn't work. Eventually, I will explain better the anatomy of a script, but for now double-click it to open it in Visual Studio. If your system do not know which program to use to edit the scripts, point it to Microsoft Visual Studio and select Always open this kind of files. So, enter on line 4 and write using Unity engine .scene management semicolon. Before the start method, add these lines. Open square brackets, serialize field, close square brackets, space string, space scene to load, semicolon. Serialize field, float, delay equals 1, semicolon. Float, counter, semicolon. We are creating variables. Inside the start method, do counter equals 0, semicolon. And inside the update, add these lines. Counter equals counter plus time dot delta time, semicolon. If, open parenthesis, counter is greater than delay, close parenthesis, enter, open curly brackets, scene manager dot load scene, open parenthesis, scene to load, close parenthesis, semicolon. Quick reference, start will run once in the beginning and update will happen every frame of your game. This variable is set up here and the delay time also here. They are serialized fields to appear in the inspector. Make sure the spelling is correct. Even a single wrong character can break your code. Very careful with the capital letters, semicolons, etc. And also, every open parenthesis should have a closing parenthesis. Every open curly bracket should have its own closing curly brackets, etc. Now, we save the script by pressing Ctrl S and return to Unity. You don't need to close Visual Studio, just save the script. Now in Unity you have the script, your component, and you need to add that to some game object. It will only run if it is up there in the scene. Because this script doesn't need to work directly in a specific object, we can create an empty object to hold this kind of functions. So right-click on the hierarchy and select Create Empty. Rename it to General Functions and drag it to the top, not inside the camera, to the top. If you select it, you can see in the inspector that it has only one component, that is the transform, because the object exists somewhere with some scale, with some rotation. Now we can drag our changing scene script to that object. The script appears in the inspector, and those serializable variables are available here to be changed. Let's write main menu on the scene to load variable and set the delay to 3. The name of the scene needs to be exactly the same. Respect the spelling. If everything is working correctly, you click on play and the main menu scene should be loaded after 3 seconds. It's working. The same behavior is needed in the win and lose screens. After a while, those scenes need to return to the main menu. Open the win screen scene and do the same as the intro and repeat to the lose screen scene. The next step to deal with scene changes is programming the buttons. Let's do something similar to the auto scene loader, using a generic script that can be used in any button. On the script folder, create a new script called ChangeSceneOnButton. Using space Unity engine.scene management semicolon in line 4. Delete the start and the update method, we don't need those. Careful, do not delete the curly brackets of the class. Now inside the class write public void on button click, open parenthesis, string space scene to load, close parenthesis, enter, open curly brackets, scene manager dot load scene, open parenthesis, scene to load, close parenthesis, semicolon. Save the script and return to Unity. Unity will compile the script, and if you don't have errors in console, you are good to go. Open the main menu scene, unfold the canvas and select the button play. Drag the ChangeSceneOnButton script to the button. It's going to appear at the end of the list of components. In the button component of the button GameObject, you have a field called onClick with an empty list. Click on the plus sign and drag the ChangeSceneOnButton component that is right there to the GameObject variable. Where it says no function, navigate to your script and to your method. As shown, this is expecting a string. This will be the name of the scene this button will load. Write it down here respecting the spelling of the scene's name. If you run Unity, you should be able to click on the play button and change the scene to the level 1. Let's now program the script to handle the quit button. Once again, right-click on Scripts and create a new C# script. Call it QuitOnButton, save, and open it. Remove the start and update methods. create a new method with this code: public void onButton quit game, open and close parentheses, enter, open and close curly brackets, and inside write application.quit, open close parentheses, semicolon. Save the script and return to Unity. Drag the QuitOnButton script to the quit button. Add a new element to the list of onClick and drag the script to the object variable. On the function menu, navigate to your method and it's done. This will only be possible to test when we build the game, because it doesn't work in the editor. Now let's code the game. On scripts, create a new C# script called GameCore. Open the level 1 scene and create an empty object to hold the GameCore script. Once the script is inside the game object, we can edit the script and start to code the game. Again, add the used in Unity engine scene management. Before the start method, add serialize field, string, win scene to load, serialize field, string, lose scene to load, int correct button. Let's use the start method to select the correct number. Correct button equals random.range, open parenthesis 1, comma, 4, close parenthesis, semicolon. In the case of integer numbers, the range is exclusive, meaning that the last number is never selected, so 1 to 3, because we will never get 4. Print, open parenthesis, correct button, close parenthesis, semicolon. The update method can be changed to public void onButton click, inside the parenthesis int from button, and have the following code. If open parenthesis from button is equal to correct button, close parenthesis, enter, open curly brackets, scene manager dot load scene, open parenthesis, win scene to load, close parenthesis, semicolon, enter, else, next line, open curly brackets, scene manager dot load scenes, open parenthesis, lose scene to load, close parenthesis, semicolon. So let's return to Unity and set up the buttons. Select all buttons and add an element to the onClick list. Drag the GameCore to the object variable. On the function drop-down, navigate to the onButton click and write 1 in the parameter box. Don't forget you have all the buttons selected, so all of them are number 1. Select the B button only and change the number to 2, and in the button C to 3. If you play the game, everything should be working. In the console, you can see what was the number selected by the computer. Let's see if winning is working. Well, I got an error in the console. This is because the script is trying to load a scene with no name. We forgot to set up the scene names. So let's fix that and give it another try. Stop the play, select the GameCore game object and type the correct scene names for each situation. Now it should be working. So I will get the correct number in every button, and after I will have the wrong button in every button again, just to make sure everything is working properly with no bugs. So, all winnings are working, let's continue to get all losings. Everything works okay. Let's build the game to play it in full screen and see if the quit button really works. To build the game, you go on the Build settings on the File menu and click on Build. Unity is asking for a location to your build and by default is pointing to the project folder. Create a new folder here called Builds. Open it and click on Select Folder. Unity will immediately start to export the game to that location. Once it's done, you just need to run the executable. And yes, the quit button works, so let's play a little bit. So let's recap. A Unity project is a folder, not a file. Your assets go inside the Assets folder. Your game is composed by scenes that are made with game objects that are controlled by components, some from the Unity engine or scripts you make. These components can be autonomous or controlled by the player, and the main game mechanics is in fact a conjunction of all of these elements. While it's possible to just go with the flow and code a game from scratch with no planning, as demonstrated, when the plan is there, it is much easier to preview what we really need to build and code. So making a project and eventually a game design document can be very beneficial to the developing phase of the game. On the next lesson, I'm going to address some code with practical examples just to clarify some grounds about the scripts. I'm hoping to have you there. See you!